Hello everyone. So far we have discussed rest, uniform motion, and accelerated motion. Rest means when a body does not change its position with respect to the observer, the body is said to be at rest. Uniform motion means it includes in itself, so rest is no change in position. Uniform motion takes into account two things: speed and direction of motion. So body is said to be in uniform motion when it is moving with constant speed in a particular direction. If the speed changes or the direction of motion changes, the motion is no longer uniform motion and it becomes accelerated motion. So accelerated motion is change in velocity. Change in velocity means either the change in speed or change in direction of motion. So a body is at rest when it is not changing its position. A body is said to be in uniform motion when it is moving with constant speed in a fixed direction. And accelerated motion means whenever the velocity of a body changes, we say that the motion is accelerated motion. Now, in this topic, we shall study how can we get accelerated motion. How can we change the speed or direction of motion, or how can a body in rest be set in motion? How can, just think of any example. Suppose this is a body kept on a surface and I want to change its position. How can it be done? I have to either push it or I have to pull it. If I pull it, it will come closer to me. If I am pushing it, it's moving away from me. It's changing its position. So it means initially when it is at rest, its speed is 0. When I push it or I pull it, it gains some speed. It means there is an acceleration into it. Same way, speed. If it is moving with some speed, I want to increase its speed or I want to reduce its speed. Then again, either I have to push it, the speed will increase. If I pull it and it is moving in that direction, I am pulling it in this direction, the speed will decrease. And same way, the change in direction of motion, that can also be there only if we apply, we either push a body or pull a body. So push or pull. This can change the state of rest or the state of uniform motion. We call push or pull a force. So force is a push or a pull. And what are the effects of a force? It can set a stationary body in motion. It can change the speed of a moving body. It can change the direction of motion of a body, or it can also change the shape of a body. If I have some object, I squeeze it, then, or I try to expand it, then the shape of the body will change. So these are all the effects of forces. Now, we said that whenever a force is applied, so I can say whenever a force is applied, there is either change in velocity or change in position. Change in position. So it means change in velocity means there is an acceleration. So we can say that whenever a force is applied, there will be an acceleration. Force is a cause and its effect is acceleration. So for acceleration, we need a force. There can't be any acceleration without a force. And acceleration means we cannot change the speed of a body without force. We cannot change the direction of a moving body without a force. We cannot set a stationary body in motion without a force. Now think of an example. Suppose I start pushing this board. If I push this board, there is no acceleration. This board is not accelerated when I am applying a force onto it. Same way, if you try to push a truck or a wall, it doesn't move. So it means, but we say that force is a cause of acceleration. If the body is not accelerating, it means the force onto it is zero. So what is happening here? Just think of this example and then answer that question. If it is an object and a person is pushing it in this direction, and there is another person pushing it in this direction, and I said both of them are applying, suppose 100 Newton force, 100 Newton force. What will be the result? The body will remain wherever it is. This force and this force, they will cancel out. So if there is no acceleration, it means the net force on this body is zero. This is the meaning of it. Net force is zero. So the body will not accelerate. Now come back to the same example. I am trying to push this wall, but this is not moving. It means the net force on this wall is zero. See, such forces we call them balanced. And if the forces are not balanced, there will be an acceleration. So when I am trying to push a wall, or even to pull it, some object, very heavy object, it will not accelerate, right? Because the forces are balanced. It means I am applying a force onto it. Maybe there is some another force on this wall and the net force becomes zero. We'll see all these forces when we study all these action and reaction, Newton's second law, Newton's third law, then we will be able to answer all these questions very well. But for the time being, keep in mind, balanced forces, if all forces acting on a body are balanced, the net force will be zero and there will not be any acceleration. Okay, now I am giving you some examples of forces which will be required when we will talk about various types of forces on the bodies, or whenever we will calculate the net force acting on bodies. Take for example, if I drop an object from certain height, I take this and I drop it, I leave it, so it will move downward. It is at rest. The moment I drop it, I leave it, it starts moving, it starts accelerating downward. It means there is some force acting downward. Which force is accelerating it? This is, I will call it gravitational force, or weight. Weight means the force with which Earth attracts Earth. So gravitational force. We will study about this force in detail. There is a separate topic for gravitational force. But for the time being, you keep in mind that whenever objects are left, there is weight pulling all of us in downward direction towards the center of the Earth actually. So this is gravitational force or weight. So for every object, there will be a weight acting downward. This force will be there. Then second, there may be another force. Suppose I keep an object on a surface. I keep this pen on this. Now, for this pen, there is weight. Earth is pulling it down, but even then it is not moving downward. It means again the forces acting onto it are balanced. This is a normal force. So whenever any object is kept on a surface, weight acts downward, but since it is not accelerating, it means the forces on it are balanced. So it means there is a force in upward direction. We will call it normal force, and they are equal. If normal force is more than weight, it will accelerate upward. If weight is more than the normal force, it will accelerate downward. But if it is at rest, it means these two forces are balanced. Okay. Another force. Suppose one object is hanging from a string, tied to a string which is supported on this string, right? So this is a string and this object is tied to this string at this point. Again, there is a force, weight downward on this object, but even then, despite this weight, it is not accelerating downward. It is at rest, and rest means the forces are balanced. So there is some another force. Which force is there? A string is pulling it up. A string pulls this object up, earth pulls it down. And if it is at rest, it is not accelerating, it means these two forces are equal. So this we call tension. So in a string there will always be a tension, and this tension will be equal to weight. So see here, these two forces are balanced. See here, normal force and weight are balanced. If this is not balanced, gravitational force, this object not balanced, so it will come down. If it is kept on a surface, then it may be balanced. This. So weight, normal force, tension. I will give you some more examples of spring force. This is spring, again just like a string, weight downward, and this spring force will be upward. If I pull it down and leave it, it moves up because of the spring force. It starts pulling it towards itself, right? Then another very important force may be object is at rest. A person is trying to push a very heavy object. Suppose we are trying to push a car or a truck, but that truck or car doesn't move when we are applying force onto it because it is very heavy, right? Now we are applying a force onto it, so on this object there is a force in this direction, there is a push. So whenever there is a force, there should be an acceleration. But if it is not moving forward, what does it mean? Again, if it is not moving forward, it means there is some another force acting onto it. Otherwise it would have covered some distance in forward direction. Whenever we push it, it should have moved, but it is not. So it means there is another force acting onto this which is equal to this force. Whatever force this person, suppose this person is applying 10 Newton and this object is not moving, so it means 100 Newton This is 100 Newton. So 100 Newton might be acting in opposite direction. What this force is? We call it frictional force between these two. So this is applied by this surface on this object, and this is in this direction, friction. And in this particular case, this is also 100 Newton, friction force. So long as the body is not moving, the applied force and the frictional force, they will be equal. That's why there is no acceleration, because the forces are balanced. Okay, so friction force is in this direction, push is in this direction, and these two cancel out. That's why the body is not accelerated. So okay, now I'm giving you a problem. Just identify the forces acting on this object. Identify the forces acting on this. We call it free body diagram. Whenever we draw a diagram and mark the various forces acting on the body, this diagram is called free body diagram. So draw the free body diagram for this object. Now see, one is this, the applied force, push by the man in this direction. But this is not moving. I am saying the object is at rest. So how many forces? This cannot be the only force in this direction, otherwise it would have moved forward. There is a frictional force, and both of them are equal. One is weight, but this object is not moving even down. There is a normal force. I have to combine various forces into single one. This object is at rest. Weight is acting down. It's not accelerated downward. It means there is a force in upward direction. So there is normal force. The person is pushing it right, but even then this is at rest. It means there is an equal force in opposite direction. So this is how we can mark the forces on any body. Force is just a push and pull, and just find out weight is one force. Then I told you about the normal force. Then I told you about the force due to string, due to spring, or there may be another force that we may call upthrust. If I take liquid in a container and I put some object, and let me say it is floating, just like this. Some part of it immersed in liquid, some parts of. So how many forces again acting? Weight is downward, but if this is the only force on it, it will sink. And if I am saying it is floating, it means the net force on it is zero. So there is a force in upward direction. We call it buoyant force. Buoyant force, or even upthrust. Upthrust or buoyant force, it is the same thing. Again, we will study these forces in the next topic. Buoyant force is the force by the liquid in upward direction. We call it upthrust also, or buoyant force. So that's all in this topic. Next class we will take Newton's laws of motion.